Experiment L04, Validity of Lumen method. In this experiment, we are going to test the validity of the Lumen method, which is a manual calculation method of the horizontal illuminance in a room. You can refer to this page for the equation of the Lumen method. For the demonstration, I will use the room EZ-S866 on the 8th floor of the block EZ of PolyU. So this is how the room looks like. There are some furnitures, a whiteboard, and on the ceiling we have the recessed type fluorescent light fittings. And the walls are white in color, and there is no window. And the floor is a carpet floor, dark in color. There are 4 recessed type light fittings, and the lamp type is T5 fluorescent tube. The first step is to measure the room dimension. And you should also measure the working plane height. And then we can use the reflectometer to measure the room surface's reflectance. To use the reflectometer, we have to calibrate the equipment by using the standard surface provided by the manufacturer. The reflectance of this standard surface by the manufacturer is given to be 86%. So I am now calibrating the reflectometer so that the reflectance is equal to the value provided by the manufacturer. Then we can use the reflectometer to measure the surface reflectance. You should measure many points and then take an average value. So in this demonstration, I have measured a few points, and after taking the videos, I measure some more points for other area of the floor. Next is to measure the reflectance of the walls. Once again, you should measure many more points and take an average value. So this is the measurement summary. We have the room dimensions, the height, the reflectances, and also the furniture layout. In order to test the Lumen method, we have to measure the working plane illuminance. So we will divide the working plane into many grid points, and the number of grid points or the dimensions of the grid points have to satisfy the international code, like the SLL code of lighting. In the section 15.2.2, grids and illuminance measurement, we have this equation, and you may use this equation to determine the maximum size of the measurement grid. So for this room, I have done the measurement, and the maximum grid size is around 0.54 meter. So this is how I divide the working plane surface into the measurement grids. So for each grid, I will use this light meter to measure the horizontal illuminance values at the desktop level. This is how I measure the illuminance for each grid. And here are the measurement results. You should comment on the measurement results according to the recommendations in the code for lighting. After collecting the data, you can use the Lumen method equation to estimate the illuminance level and check if it is consistent with the measurements. In order to use the Lumen method equation, we need to collect some information of the lighting system, like the capital letter N, the number of luminaires in the lighting system, the small letter n, the number of lamps in each luminaire, F, the initial luminous output of each lamp, that is the lumen value, and the utilization factor. From this picture, we can see that there are 4 luminaires in this lighting system. So the capital letter N will be 4. And we need to check F, the lumen output value of each lamp in the luminaire. So in this picture, if you look closely, you can see the lumen output value of the fluorescent tube, which is 2100 lumen. For the small letter n, we can see that there are 3 lamps in each luminaire. So the small letter n should be 3. But you can notice that one of the luminaire has only 2 lamps. So when you do the Lumen method equation, you have to make an adjustment. This is the lighting layout plan, and the top right-hand corner luminaire has only 2 fluorescent tubes. For the utilization factor, UF, you may use this figure, which is extracted from the IESNA Lighting Handbook. You may now use the measurement data and the lighting system parameters to check if the Lumen method equation is valid or not.